be right here, these videos again. And audio quality might be kind of lacking today, but that's alright. So today we're going to be doing another problem, but today we're going to be sketching a graph, or sketching a curve on a graph. And so we got the function y equals 2 minus 2x minus x cubed. So the first thing we got to do is find the domain, and then that's just going to be all real numbers because it's a polynomial. And then the other way around is negative infinity, comma infinity. Alright, and then the y-intercepts. To find the y-intercept, all you got to do is plug in 0 into the function for x. So we got f of 0 is equal to 2 minus 2 times 0 minus 0 cubed, which is going to give you 2. X, using Newton's method, after a lot of trial and error, you're going to get approximately 0.77. And then as for symmetry, it's not going to have any symmetry because we have 2 odd powers, being x cubed and x to the first, and then 1 even because a constant is treated as an even. So there's no symmetry. Okay. And then as far as asymptotes go, there's none of those either because the function is a polynomial. Okay. And the next we're going to be looking at whether or not where it's increasing or decreasing. And to do that, we need to look at the derivative. So if we call our function f, so we got f prime of x is going to be equal to negative 2 minus 2x cubed, which is also the same thing as saying negative of 2 plus 2x. That's supposed to be 3x squared is what that's supposed to say. That looks like crap, so I'm gonna fix that. So, okay, yeah, because the derivative would be 3x squared. Go ahead and fix that as well. Let's chop it off there. Alright. So again, sorry about that. Okay, so that's gonna put that there. Okay. So then that means that if we look at where it's increasing, so it means it would be, which means it would be sorry about that, my audio cut out. Alright, so it's going to be less than 0. So when that's less than 0, it's going to be okay. Well, it's not greater than 0 at any point. At any value you plug in the negative of that, it's going to be negative. So it's decreasing on all real numbers. And then since it is always decreasing, there's going to be no extrema, no local maxes, no local mins, anything like that. And then for concavity, which is our next thing, we're going to be looking at the second derivative. So I'll call that f double prime of x. That's an x. And that's just going to be equal to negative 6x. And then on the interval, and then it's going to be greater than 0 on the interval from negative infinity to 0, and so that's going to be concave up. And then it's going to be less than 0 on the interval from 0 to positive infinity, and that's going to be concave down. And then the point of inflection, I wrote that up here, point of inflection is going to be at x equals 0. So again, 0, and then we found out earlier that the y-intercept is going to be 2. That's where it's going to so we already marked that point on the graph right here. And so then the next thing is to draw the graph. and so it's going to be decreasing all the way down, and it's going to be concave up from that point, and then it's going to then flip and then continue on there. And then the x-intercept, as I found out before, was 0.77. It's just going to flip over here and put that arrow right there, and then you are all done